Good afternoon and welcome to our webinar today, Data Platforms, Choosing the Right Tool for the Job. So, before beginning, I will introduce you some organizational points. The webinar will be recorded and will be available at our ATE website and also at our YouTube channel. You will receive after the webinar an email with the link to the recording. You also can ask questions in the chat, private chat tab on the right. And the questions will be answered at the end of the webinar in the Q&A session. Only we, the speakers, and me can see the questions you ask. And if you had any problems, please don't hesitate to contact me at marina.rubio@alexandertam.com. So we have today Dr. Matthias Lein, our Chief Technology Officer, who will do the webinar. So thank you, Matthias. Enjoy it.
Well, thanks, Marina, for the kind introduction. And welcome to the audience to this webinar. It's been held previously in German, but because of the many requests we got afterwards, we decided to hold it again, this time completely in English. As you've heard during the introduction, we're going to talk about data platforms and all the components thereof. So let's briefly have a look at the data engineering lifecycle. Most of you, I'm sure, are familiar with this, but let's have a look at the individual components one by one, because this is how the webinar is structured as well. And we're going to have a look at the technological components that underpin the engineering lifecycle. So at the very start of the data engineering cycle is always the generation of the data. This could be IoT data if you're in manufacturing. This could be, of course, other data systems, maybe your transactional systems that have your, I don't know, customer data you're purchasing. Could be an ERP system that's completely open, and data platforms could be expected to ingest all of this data. But of course, the kind of platform you choose and the technology that you bring to bear depends strongly on the type of data and also what you want to do with it. The first step then, bringing the data into the platform, is called the ingest. And that is usually not enough just to load the data into the platform. You also need to transform it into some sort of state or format that you can actually use before you take the data and serve it as a product to do analytics, for example, or machine learning on this data. Underpinning all that is, of course, some sort of storage technology where you put the data and keep it persistently so you can reuse it and aggregate it over time. Other aspects of data platforms, which we call undercurrents here, are, of course, the kind of governance that you bring to bear on your data, which should be part of your data strategy. And then, of course, there's also an orchestration layer that makes sure that all these steps that I've mentioned previously are taken place in the right order, and, for example, also automatically rerun on failure, or if you're working in a batch mode, for example, rerun daily, weekly, monthly, or whatever the cadence is of your data ingest. All of this lower part is usually known as data ops. So this is the operational aspect of your platform that has a little to do with technology, but not exclusively. So this is actually part of your data strategy. So if you don't have one, go ahead and build yourself one. So why do we want to do data engineering and data science at all? This is something you need to keep in mind when you're building your data platform. Just keeping the data and storing it away isn't enough. We want to create value from data. That's not just the motto of our company. This is what you should be looking at in the first place when you're thinking about building a data platform, a completely new one, or if you want to refurbish or migrate an old one. So at the very bottom there is, of course, the collection of the data. I've mentioned that already. Then you usually need to move it onto the platform, transform it and aggregate it. But then, of course, higher up in the value chain is what you can learn from the data and then create insights from it. And each one of these steps has different needs, but it also leads to different business outcomes. Clearly, what you want to do is some sort of analysis at the very least, but you're probably preparing data products to generate even more value because you want to do some sort of machine learning on it to get to AI insights or build AI-enabled products on it. Right? Let's not forget, this is sort of the pinnacle of this pyramid. This is where we're trying to get to. This is not what we start with. right? Just like in the olden days, data scientists spend about 80% of their time extracting and cleaning data. And as you can see, this is very much on the lower ranks of this pyramid. But this is really where a good data platform can bring all its grunt to bear and take the load off data scientists' shoulders. Another aspect that you need to keep in mind when you're deciding on a data strategy and the kind of data platform you want to build is where does it actually fit within your organization? This is really a question of your organization's maturity. So we've got a maturity assessment here. We've got 4 stages here. We call them the starting stage, the scale-up phase, the maturity stage, and then, of course, there are also those that actually lead the field in terms of their maturity. You should be doing this kind of assessment for your own organization or for the part of the organization where you're in, because this also informs you what kind of technology you should or shouldn't use in your platform. Not every platform is the right tool for the job, and not every technology is actually right for your organization. Of course, everybody aspires to be a data leader, but not everybody has actually the use cases to be a leader in the space, right? Don't compare yourself to Google or Amazon or even Zalando if you're not actually cracking the same kind of problems there. So let's have a look. How would you determine that you're sort of a starter in the data realm, right? It's usually best to do this assessment by looking at the kind of challenges you face. So the challenges we have here in the starting phase are, for example, that you don't have a single source of truth, right? This usually means that you're keeping data in disparate sources, that maybe data is even duplicated, and in the end, nobody really knows where this source of truth lies, right? This kind of assessment usually means that you're starting on your data journey and that you still have a long way to go. Usually what that means is that people don't trust their data, right? I mean, who hasn't been in a meeting where the first 20 minutes are spent on a discussion who actually brought the best data and which source did you bring your data from, right? This sort of discussion shouldn't be happening in an organization that is sort of a couple of steps ahead on their data journey. That also usually means that everybody is spending a lot of time preparing the data for these meetings, right? That shouldn't be the case. If you're sort of already scaling your data operations, these kinds of reports, dashboards, and analytics should be happening automatically. You shouldn't be the ones putting the work in. This should be happening automatically. So let's have a look at the scale-up phase in terms of data maturity. If you already have automation, right, if you're orchestrating data pipelines, that means that you're sort of scaling up. And again, right, data maturity can be different for different parts of your organization. Maybe your central IT is already completely mature, but some of the other departments that also do a little bit of analytics are sort of lower down on the ranks of in terms of maturity, right? But yeah, once you get to the scale-up phase, it should be fairly easy to share data across the organization, right? And by sharing, I mean sharing access to the data, not duplicating it, not copying it from one system into the other. And scale-up also means that you've put some thought into data governance and compliance. Of course, really mature data organizations are already operationalizing data projects, right? You start offering data as a product on your platform. You've thought and implemented data quality in your platform. You actually have a dashboard that tells you how good the data quality is, and you're taking action to remedy bad data quality or monitor the sort of development over time in terms of data quality, right? That usually means that you have not just one data team, but several data teams in the field that are looking into this and professionalizing it along their way in every step. Now, this mature state is what we actually recommend to most of our customers. This is enough in terms of maturity for most organizations. You don't need to be a leader in the field unless you're cracking the really big questions. If in terms of big data, right, we all remember the 3 V's, right? There's volume. So if you have really a lot of volume in your data or velocity, right, if the data is coming at you with a lot of speed, or if you have a lot of variety, right, if you have many different kinds of data, right? If you're in those sorts of situations, you probably should be a data leader. You have to bring all the latest technologies to bear on your platform. This might be a good justification for it, right? Most organizations don't need this, and they should be at the mature stage and not at the leading stage. So let's have a look at data architectures. There is, of course, also an assessment to be done here, right? We want to pursue best practices, but what does it actually mean? And we've defined 5 areas here that tell you that you are pursuing best practices in terms of your data architecture. The first one is, of course, operational excellence, right? So this is the ability to support the development and run workloads effectively, right? You actually gain insight into the operations and you continuously improve those. What does that actually mean, right? You should be performing everything as code, infrastructure as code, pipelines as code. You're probably not using a low-code, no-code tool for all your platform operations because these usually can't be versioned. Some of them, okay, you can put them into a Git repository, but that's quite often just a JSON blob, and it's really hard to track changes sort of in a visual way through a Git diff, right? Don't use these tools. It's not operational excellence. Use everything as code. Right? Keep it in a repository, have code reviews. This is operational excellence in terms of data operations. Security is a big aspect in terms of best practices, right? You need to be able to protect your data and the systems from outside attacks and internal carelessness, right? Especially when we're thinking about GDPR, personal identifiable information, this should not be even shared accidentally. Of course, if you're sort of in the governance spheres, you might have confidential or secret data and completely different rules apply there. And don't forget about the AI Act that is coming into force in the European Union soon, right? You need to be thinking about this now. So implementing the principle of least privilege is a good start. Automating access and also the expiry of privileges is a good idea. And you, of course, need to encrypt your data in transit and at rest, right? It's usually just a tick box in your platform automation, but you need to make sure that it is actually ticked. Now, reliability is a best practice that everybody should aspire to because otherwise people will lose trust in your platform, and with it goes the trust into the data. And as we've seen in the maturity assessment previously, low trust in data is never good for an organization. You need to make sure that your platform runs reliably enough that people trust you and the platform. But there's also, of course, a technical reliability. You need to be able to scale vertically or horizontally in order to meet the needs of your platform. Sometimes you will provision a platform and you know that until the end of days, the platform is going to be big enough. If the business proposition is like that, it's possible. But sometimes the platform needs to scale with your business. So if your business grows year to year, you need to make sure that your platform can grow with it, right? And then, of course, the next 2 steps are very important as well, but these are sort of for the more professional, more mature organizations. Cost optimization, right? Can you actually scale up and down? Do you have an elastic deployment? So you only spend what is actually necessary, and you don't have an empty running data platform that you're paying for 24/7 if you're only using it for 2 hours in a week, right? Cost optimization is a big deal for a lot of our customers. You probably have heard of FinOps. So that means having the financials of your platform, prices and elasticity in mind from the get-go. But this is certainly not something you should be starting with when you're actually only along the first few steps of your data journey. Now, sustainability is a biggie. There is going to be more and more complex ESG reporting coming most of our ways. And this is something you need to be aware of, right? So where's actually the power coming from that powers your data platform, right? What is your local power provider if you're running it on-prem? Where does the data center that your cloud provider draws its power from, where's that energy coming from, right? Is it a coal-fired coal plant? Is it some sort of sustainable energy source? These are questions you need to ask yourself if you actually want to run a sustainable operation. But you also need to be sustainable in terms of your data, right? Uncontrolled growth is also a financial question. So you should be able to remove unneeded or redundant data. You need to be able to delete personally identifiable information on request. That is also in the GDPR. And of course, you need to be able to retire components that are no longer needed. So you need very good visibility onto your platform, monitoring and logging that actually enables you to make those kinds of decisions. So now that we've talked about a couple of best practices, let's have a look at what kind of data architectures are actually available to us. And there's a list here, together with a maturity assessment. This time, not a maturity assessment in terms of the organization that is running it, but a maturity assessment in terms of the technology itself. And of course, top of the stack there is the data warehouse. This is a very well-known technology. They've been around for decades now. And of course, you can just buy them off the shelf, either from one of the big providers or one of the big cloud providers. You basically flick a switch and you have a fully functioning warehouse. That is not to say that the configuration can't be complex or even difficult, but the technology itself is very mature, and there's a lot of talent on the market to run those data warehouses. So whenever a data warehouse fits your use case, you should be going for that. For maybe a decade now, the next technology down the list has been very popular, data lakes, of course. Big advantage there is that you can separate compute from storage and you can scale them independently. This is something that we are seeing more and more now in data warehouse technology as well. But back in the days, data lakes were really the only data platforms that could do this. And of course, you can store structured and unstructured data at any scale in those, right? This is really the proposition of a data lake. The maturity is actually quite high as well these days, but there are a lot of components that are difficult to automate still, and you need to run them pretty much on your own. And there's a lot less talent and a lot less well-documented use cases for the data lakes. So of course you can have one, but if the data lake technology that you chose actually fits your use case is a complicated assessment. And that's why I've scaled down the maturity assessment here, because you really need to be an assessment. It's not as highly automated and working out of the box as data warehouses do. Of course, you can spin up a data lake in one of the big cloud providers. But like I said, if that is always configured the right way, is not to say, and you might be paying big bucks for an architecture that you don't actually need. An approach that actually makes this a little bit more easy is the data lakehouse approach, pioneered by Databricks, but now also available through other technologies, right? So the Delta Lake file format is one of them, but we also got Hudi and Iceberg by Apache that basically implement the same technology. And the idea behind that is, of course, that we all love relational data. We all want tables and we want to query them with SQL. We want to have asset guarantees. This is something we had in the data warehouse and something that we lost when we introduced data lakes, right? And the lake house sort of brings that back, trying to choose the best of both worlds. We've got asset guarantees. We can query our tabular data. And let's face it, I mean, everybody loves working on tables in traditional relational databases. And this is what you get back with the lake house. And because big companies back these projects, they're actually easier to configure than data lakes. This is why I've moved the slider a little bit more along. Even though there's data lake technology underneath, the sort of technological variety you get and the whole breadth of possibilities is smaller, so it's easier to configure. And I would actually rate it as a bit more mature than data lake technology, even though it is a younger technology. What works really well out of the box is what we call the modern data stack. These are all these software as a service companies that you find on the internet. You can just Google it. You find big tapestries with lots of logos on it. I mean, my personal favorite there is DBT, the data build tool. It's an open core project. You can just download it for free and build your data lakehouse on it if you want. But it's also available online as a software as a service offering. And most of these are very modular. They work really well together, and you can build yourself a data platform very easily with a few clicks. Of course, it comes at a price. The modern data stack isn't cheap because these companies are usually venture-backed and they need to make a profit. And they develop their products at very high velocity. So there's certainly a price to pay, but technologically, you would be at the forefront and you would have a very good, very stable data platform. The next two technologies, Kappa and Lambda architectures, are for streaming. And this is really something for professionals. There is not a lot of talent in the market that can build you a Lambda or a Kappa architecture-based data platform. It is possible, and in some cases it's absolutely necessary, but this is really for experts only. And there are very few solutions that you can just buy in the cloud out of the box that are so well configured that they will cover all your use cases. So this is something for very mature organizations or organizations that actually produce data in a manner that fits streaming technologies. The last point there, data mesh is of course not a technology. It's more a paradigm, an organizational approach to running data platforms and to connect data platforms with each other. I mean, Zhamak Dehghani's book has been out now for, I think, about 2 years. And those 4 pillars of the data mesh give you a rough outline of what makes a data mesh, but there are no concrete examples or hints or instructions in that book. So everybody is still sort of coming around to the idea of a data mesh and what it actually means in every individual organization. So data mesh is a very good concept, one that we have implemented at several of our customers' data platforms, but it's highly individualized usually because you need to work sort of brownfield with existing data platforms and integrating new ones. And of course, there's a lot of organizational change that usually comes with introducing a data mesh architecture. So this is not really a technological question. This is really organizational and people management, introducing new data structures to actually back that up. Okay, so let's have a quick look at all these individual technologies. So data warehouses, right? They usually serve as a central hub for reports and analyses that is usually normalized and very structured. I mean, everybody's seen a diagram like I've got it on this slide on the right-hand side, right? Usually you've got a couple of data sources, you've got some ETL system, and then you fill up your warehouse, usually some core tables, you build a couple of data marts that you read from. This has been around for decades, like I mentioned, and usually comes along with some BI, so business intelligence, right, which means analysis, reporting, dashboards. These are still the best sources of tabular data. If you've got sort of relational database needs, then you should be going with a data warehouse. And I guess most of you who are interested in data platform architectures have one somewhere in their organization. But even if you're trying to introduce a new analytics platform, have a look at the data warehouse architecture first, because like I said, it's been established. It's a real workhorse, and it might be the right solution for you. Data lake, like I said, is a slightly different concept. We can scale compute and storage separately. And for some reason, diagrams for data lakes are always sort of like bottom up and not left to right like we have in data warehouses. It's a law. It's always like that. And of course, you can store structured and unstructured data in a data lake. That's something that also really differentiates it from a data warehouse. So for example, if you have visual data, if you've got images, if you've got videos, or if you've got semi-structured data, right? If you're getting JSON blobs from an IoT platform or somewhere from social media, this is definitely the right technology for you. Yeah, data lakehouse would be the same thing pretty much as a data lake, but you have this SQL layer on top that enables you to query your unstructured data through a SQL interface with asset guarantees. I've mentioned that already, right? So modern data stack, like I said, is highly modular. It's a plug and play architecture that you can click together from different sources on the internet. And there's a lot of variety there. So there's also a little bit based on personal preference, which products you want to use. And you have to, of course, be comfortable with your data going into the cloud. This is pretty much a done deal with a modern data stack because it is software as a service. And you might be wedding yourself to a particular cloud vendor if the offering that you have in the modern data stack is only available on one of these platforms. Usually they're multi-cloud or available on different cloud providers, but that is not actually true for all of them. I've already mentioned streaming, right? So Lambda architecture, usually you combine batch processing with stream processing. You have some stream processing to be very quick, but you combine it with batch processing for the more aggregated data and the more long-term storage. If you can't have that, if you need everything streaming very quickly, Kappa architecture would be the right tool for you. Think IoT devices. If you've got a shop floor or a manufacturing floor where you've got lots of sensors, think a car fleet that is live streaming data over 5G or 6G networks. This is when you actually need streaming architecture. And a data lake or a data warehouse just won't cut it in that situation. Okay, like I said, data mesh is more of an organizational principle built on 4 pillars, right? So you would have data as a product. So that already tells you that with the data mesh architecture, you really have to go into sort of the DevOps, DataOps, MLOps mode of operations. It's not just a project that you finish and then it's done. You define a data product, and then you continuously improve it. So there's a feedback loop involved as well. You will have federated governance, which is often the hardest part for data mesh architectures, because federated actually means working together. It's not distributed data governance where everybody is working in their own silo. So when people say, well, data mesh just means that I can keep my silos and I just need to connect them, that is not true. The federated governance introduces a level of collaboration and cooperation that silos could never achieve. And then you have self-service analytics. So making access to the data easy is also a core concept of a data mesh. And this is something that is very important in order to achieve the kind of acceptance you need, right? Data mesh is often about connecting different departments with a central platform. So one of the ways to implement a data mesh is sort of what we used to call hub and spoke, right? So you have sort of a mother architecture somewhere in the middle, but then you're along the spokes, you've got smaller data platforms that you can also raise up, and they need to collaborate. That's often an issue in organizations that are not very mature. People want to hide their data. They don't want to share it because then they will be held accountable for the data quality in it, right? If you're facing these kind of barriers, you need to break it up, introduce federated governance to enable this sort of self-service access to the data, because otherwise you would never get this. You see, the last bullet point there is data mesh requires a shift in organizational culture, and this is hard. Okay, let's talk about tooling a little bit. We've had a look at the data lifecycle, and I'm going to go through them one by one. We're not going to talk about the generation of data because this is really something that is very unique to each and every data platform, but we are going to talk about storage, ingest, transform, and serving layers, and I'm going to give a couple of comments about governance and orchestration layers as well. Okay, so storage should be the easiest part, right? Everybody's got a file system, or maybe you even know what object storage is in the cloud. But of course, there's a huge variety of technologies that you can use for your data platform. The question is really, is it small enough so you can keep it all in the box? Does it have to be distributed? Do you need remote backups? Do you need to have it in different geographical areas, right? Not every technology is there the right tool. And I've brought with me here a little bit of a tech radar view on different storage technologies. You probably know this from our website, right? So we sorted into adopt, trial, assess, and hold. Adopt usually means this is something that we recommend for production. Trial, the trial column usually tells you that you could look at it. It might not be production ready depending on your use case. The assess column is usually reserved for technologies that are either very new or very niche. So they might be production ready, but then you would be facing a very particular niche use case, or the product is so new that we're not really sure about its maturity yet. And of course, if we set a technology to hold, then you probably shouldn't use it at all, or at least we don't recommend it. And if you're running it in production right now, we do recommend to retire it, or at least plan a migration out of this technology pretty soon. So what do we have in the adopt column here? So you see all the cloud vendors blob storage, so that's object storage. They're all good. Of course, Kafka would be a storage system as well if you're facing a streaming platform. And in general, we're talking about the S3 interface. So this is AWS's object storage, and they pretty much define the interface with which we talk to object storage. So anything that comes with this interface is usually a good technology. For example, on-premise, we're recommending MinIO. MinIO also has an S3 interface. But also OpenShift container storage, which has Ceph under the hood, is something that you could run on-premise if you need to decide on a storage technology. So let's have a look at ingest. So ingest means bringing the data from the data sources. This could either be source systems or maybe something you scrape from the web if you're monitoring social media, for example, or it could be the IoT platform that I've mentioned earlier, where you might have sensor arrays that's streaming data into your platform, right? So, and there's a couple of buzzwords that I've already knocked over to consider here. So we've got streaming versus batch processing. So is there a continuous stream of data coming in, right? Or is it something that we load monthly, hourly, daily, weekly, right, in batches? This is something you need to know before you decide on your ingestion technology. And then, of course, different technologies are better for different use cases. So, for example, with a data warehouse or any relational database, we usually talk about ETL jobs, right? So this is extract, transform, load. And there the transformation step comes before you put it into the platform. The reason for this is that in relational databases or data warehouses for that matter, you have a data structure, the schema already given, and you actually cannot store data in any other format, right? So you need to transform it before it lands on the platform. And this is not the case with data lakes, right? So here we talk about ELT processes, right? So extract it from the source systems, you load it onto the platform, and then you only do the transformation if you are doing the analysis, right? So that's possible on a data lake. And of course, this is something you need to keep in mind when you're deciding on ingest technologies. So here you see a lot of the usual suspects, right? So Azure Data Factory or Synapse now, the newer technology, probably Fabric in future, is something that we see very successfully implemented at a lot of customers who use Azure. But if you've got Snowplow or Fivetran or any of the other technologies at other cloud vendors, these work equally well. And of course, on-premise, we often have things like Kafka or Airbyte. And then, of course, Spark is always a useful technology to ingest your data. Actually, it's the underlying technology under many of these systems that I've already told you. Underneath, there's often a Spark cluster that is running. Okay, so then next would be the transformation layer. So you need to transform your data to do anything useful with it. When you're talking about a data warehouse, you're probably already doing it during the ingest process. And some of the tools that you will see on the next slide also are being used for data ingest, right? But once you've got your raw data on your data platform, be it a data warehouse or a data lake, it needs to be transformed further, either because you want to aggregate it, right? You want to create value from one data source, or maybe you need to harmonize something from more than one data source. Often the real value in an analytics platform lies in the fact that you can draw on many sources to draw your conclusions on. And that means you need to transform the data to actually make them useful and have them fit together. Yeah, so for data transformations, we have many of the well-known technologies, like, for example, Redshift, which is a Postgres-derived distributed database that AWS are offering. But of course, there are many other technologies like MongoDB, right? For semi-structured data is something that we see implemented and used very successfully at customer sites. But there's also a personal favorite of mine here in on-premise, in the on-premise row, but in trial. So DuckDB is an OLAP database, an in-process database that we have used successfully at many customer sites. It's a relatively new project. They've been around only for a very few years. But for analytical queries, it's been used very successfully. So if you haven't seen DuckDB yet, I would recommend that you have a look. Yeah, so the serving layer, so making sense of the data that you've just ingested and transformed is the next step then, usually, because you need to make sense of it. And there we've got, of course, all the usual suspects in terms of BI tools. So I guess everybody in this call has either Qlik or Power BI or Tableau somewhere on the platform. And to be honest, they're all good. The cloud vendor solutions are coming along. And if you have a very small but limited use case, they might be good for you. But you can see that we don't actually have any offerings from the big cloud vendors in the adopt column. Of course, you can use many of the technologies that we have in the adopt column also online. For example, Power BI would be served through your Office subscriptions, but this is somewhat different than the offerings from the big cloud providers. That's why we have moved it into the on-premise slot there. But at this stage, we cannot recommend to using Azure's or AWS's or Google, for that matters, solutions. The Google Data Studio is good, but it's not really suitable for most of the use cases that are implemented in Qlik, Tableau, or Power BI for more professional use right now. Now, orchestration is also important because you need to make sure that your processes run on time, that they're, for example, rerun when they fail, and that you're always up to date and you actually know how up to date or how timely your data is. Here, we recommend products like Airflow, for example, that you can run on-premise, but also through the cloud providers as a service. Other tools like Dagster, for example, which is in the trial column here, have been used by us very successfully with clients as well. It has a very nice integration into dbt, for example, that gives you sort of the data lineage and data documentation out of the box in a nice interface. I can recommend that as well. But of course, the big cloud providers have their own solutions as well. For example, the Azure Data Factory works exactly identical in the Azure Synapse platform as well. Those are the kinds of tools that we recommend for data orchestration. So for data governance, we usually talk about the technology part of data governance, right? So you still actually need to sit down and write a data strategy, but usually that involves some tooling that helps with governance as well. Often that comes in the guise of a data catalog, for example, Purview in Azure, or the AWS Glue catalog. And of course, there are other products that you can buy from certain vendors. Be aware, though, that these tools only support your governance. And I don't have the slide here with me, but in our data strategy maturity assessment, we sort of map a road line to good data governance. And I don't remember if it's 5 steps or 6 steps now, but what I do remember is that the introduction of a data catalog is actually the last step of your professionalization of your data governance. So keep that in mind as you're building your tooling around your data strategy to implement good data governance. The introduction of a data catalog should come last. And with that, we're sort of at the end of this webinar as well. And I've mapped out sort of one standard solution that we often introduce at our customer sites, right? So for example, we would be using Delta Lake technology. So that would be a lakehouse. Orchestration usually is done by Spark. Depending on the volume of data, we also use other technologies, right? I mean, if it's small enough to fit in memory, there's nothing wrong with Pandas data frames. You can achieve greater throughput using technologies like, for example, Polars or Dask as well. But if you've got the amount of data, or if you're maybe by a choice of your IT department or your data strategy bound to certain platforms, you will not get around to working with Spark. So it's a good skill set to have, and it's a skill set that is also available on the market. So that's why it's always definitely at least a fallback technology. In terms of operations, and we do a lot of artificial intelligence and machine learning use cases, we like MLflow. just because it is one of these standard tools. That's something that I didn't even have on the slides previously. So if you find yourself within these use cases, come talk to us, and I can go into more detail for your own data platform and what might be the right technology for you. And with that, I'm at the end of this seminar. Thank you for your patience with me, and I will be having a look at the questions that have been coming in and enter the Q&A. So where is it? Chat here. Question. Why do we not suggest HDFS anymore? And follow-up question, is HBase also out of date in your opinion as data storage? So HDFS is, of course, still a technology that underpins a lot of the technologies that we actually do recommend. But doing your own HDFS installation is very cumbersome, and it's not very easy to set up and orchestrate. So that's why we're not recommending it. You should be buying one of the products that has HDFS under the hood, and just use it out of the box and let someone else do the operations. That's what we mean by not recommending HDFS anymore. So could you also give your opinion on how you see that in the context of data spaces, for example, the Eclipse data space components like Catena X? Actually, I'm not really familiar with the EDC tech stack. Data spaces, well, if you're asking this kind of question, you're already very far along your journey. And I think this is something we should probably talk in private about. Okay, another question. Should I switch to any of the technologies you recommend today if I already have a running setup? Yeah, that's of course a very difficult question. Probably not. If you have a running system, you need to scope out what the lifetime of this data platform could be and should be, right? If there are any technologies that we're not recommending here, there might be limited life in the platform, but it also depends on your company's goals, right? Are the use cases that you're running on this platform still going to be around when this platform has to be retired from a technological perspective? Can you migrate those use cases onto another existing platform? These sort of should I refurbish, should I replace, should I migrate question is a difficult one. Probably not right now would be my answer to this question, but you should be planning a successor platform if you're using any technologies that we're not recommending here. Why is a lakehouse necessary? Don't most data lake technologies have a SQL interface already? Yeah, that's right. Most technologies, like I think HBase was mentioned in another question here as well, they do have a SQL interface. And of course, one of the motivations that I've already mentioned is that everybody likes to work with relational databases, right, and SQL queries. But that's not the only reason. The technologies that underpin lake houses also give you asset guarantees, right? So these are these strong guarantees that make sure that the data is actually always consistent. And this is something that is not just nice to have, sometimes it's absolutely necessary to have. A lot of the other technologies that come to bear in data lakes are not asset compliant. The acronym we use there also comes from chemistry. It's called BASE. And the E at the end of the BASE acronym stands for eventually consistent. So when you write data into one of these platforms, it's not guaranteed that the next read operation actually finds this data again, right? It could be some time before it actually shows up. So if you need guarantees that you have consistent data always in your data platform, you either need to use a data warehouse, which also gives you asset guarantees, or a lakehouse technology. And always read what's written on the tin, because some of those so-called cloud data warehouses also don't give you asset guarantees. So if this is something that you're after technologically, definitely have a look at the documentation so you're not surprised afterwards. Okay, one more question maybe. Are there advantages to using all components from a single source? For example, all AWS services and no tools from outside this ecosystem. Yes and no. I guess the biggest advantage that you have is that there's one common skill set that you can train your staff on. So just to stay within this particular example, if you have AWS solution architect qualified engineers on your platform, this is pretty much all you need. It all comes from one vendor, and the technologies all work very well together. This is certainly nice because the data also never really leaves the ecosystem, which is usually very expensive with cloud providers. So for example, if you connect some AWS services with some Azure services, the transfer between AWS and Azure is quite expensive. Of course, that might not matter to you either because the use case is so beneficial to your business that you don't mind incurring the cost, or maybe the data that is shipped between the two cloud providers is very small and it doesn't actually incur that much cost. But in our experience, copying the data around is a real anti-pattern, and it does create more cost than a lot of our customers are prepared to buy. Of course, you also need to have a look at vendor lock-in. This is usually the concern that some of our customers have, right? And this is sometimes the reason why they want some components of a data platform in AWS and others, for example, in Azure or the Google Cloud Platform. But that makes it very complicated. And if you look around, there's actually a Gartner report that tells you that companies who using a single cloud provider for all of their services are more successful, and that multi-cloud installations and platforms fail more often than single cloud provider source platforms. Okay, well, thank you for your patience again with me. I think this is all the time we have. And with that, I would say goodbye and have a good day.